Welcome back. In this video, we're solving little number 4, median of two sorted arrays. So we have two sorted arrays, nums1, nums2, of different sizes potentially, and we need to return the median of two sorted arrays and in O of log n plus n. So my approach to this would be to determine how many elements. So when we get median, we split essentially array in two parts. One part it's less than median, and other part is greater than median. In my case, I will do the thing where if I have odd number of elements, if we have odd number of elements, that's this situation, then the median is in the elements. But if we have even number of elements, then median is average value of two, so one highest on the left side and one smallest on the right side. Not necessarily from nums1, nums2, but depends when we have it essentially from here. So median is the average value of this, and here is median, this number. So my approach would be to try to determine how many elements from it's 3, 5, 9, and 1, 2, 3, 4, 5, 6, 7, something like this. So these are two arrays, and I'll try to determine how many elements, this is my task, how many elements from the first array should I use on the left side. So let's imagine we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so 5. I suppose if we choose two elements, so since we have 10 elements, we essentially know that on the left side we have 5 elements, on the right side we have also 5 elements. So when we split here, we know that we need to split also here. And what do we have to check? We have to check if this number is smaller than this number and this number is smaller than this number. In this case, this is not correct, so we'll have to use we'll have to use so if this one is greater than this one, then we have to move back and do it like this. So we'll take it like this, and we found our midpoint. So we have 1, 2, 3, 3, 4 on one side, and 5, 5, 6, 7, 9 on the other side. So that's essentially the idea. I'm choosing how many elements I use, so 0 up to 3, using binary search. So let's code this up. And one is length of nums1. I apologize for the sounds, I'm in common space. So nums2, and if n1 is greater than n2, then I want to flip them, because this would lead to some unnecessary complications. So we'll do this. And what else? So first we'll have a target number on the left side, which will be equal to n1 and 2, but we'll also add 1, so that when we divide it by 2, it's always correct number. And for the odd number, I will store the median. For the odd number, like this situation, I will store median on the left side, just so it's easier for me. So let's maybe pull this a bit up. This can be start is 0 and is n1, but I'll use +1, y +1, so I can choose also, let's say 3, because if n is 3, I'll never use 3. Because 2 and 3 is 5 divided by 2 is 2.5, so yeah. Okay, now we go to the while loop and I'll choose test. Test is start plus end divided by 2. And I have to get this. So left side number 1. If we use 0 elements, then we need that comparison to be true. So I will use minus float if test is equal 0, else nums1 of test minus 1. So similar thing for the right side. So for the right side we'll use float infinity if test is equal to all the elements, else test minus 1. That should be correct. So if we use 2 elements, or if we use 2 elements, then so if we use 3 elements, if we use 2, then I want third to be okay. This is good. And for the right side, similar. For the secondary, similar thing. So Ln2 Rn2. So it's float infinity if we don't use any elements, and that situation where target is already equal, I suppose, test. And if we have to use 1 element, then we use 0 index. Okay, so this should be nums2. Or if we've used all elements, so if we have 3 elements and our target minus test is all of these, then we use infinity. But if it's 2, if it's 1 less, if it's 3, then it's equal to this. If it's 1 less, I think just this is enough. And now I think we got idea with this, so just to keep it on one. So there is 2 conditions. If ln1 is greater than ln2, I have to use less elements from first array, so end will be test, and I will continue. And if ln2 is greater than ln1, I have to use more elements, so start is equal to test, continue. And now I have 2 situations. So if n1 plus n2 is odd number, then I return max of ln1, ln2, because this is only happen when these 2 didn't happen. And in other situation, I just return max on 2, 2 divided by 2, and this should be it. Seems to work, and it works. Okay, yeah, here's whole code. Stop it if you need it. Let's check the space complexity. So time complexity here, as we know, should be O of log min of mn, I suppose. And space complexity, I haven't stored anything, so of 1. Nice, so nice, and of 1 because I haven't stored anything. Yeah, so I hope this was clear. If you have any questions, leave them in comments. Have a nice day and see you in the next one.